Hi, I'm Peter Deutsch, and this is the lightning talk for Metior, a comprehensive model to evaluate obfuscating side-channel defense schemes. Microarchitectural side channels enable an attacker to exfiltrate information via the observable side effects of a victim's execution. Defense schemes which protect against these side channels can be broadly classified into two categories: partitioning and obfuscating. Partitioning defense schemes completely isolate a victim and attacker's access patterns, ensuring that the attacker cannot learn anything about the victim's accesses to the shared resource. While partitioning schemes offer total security, their inflexible nature can significantly degrade system-wide performance. In contrast, obfuscating defense schemes, such as randomized caches and traffic shapers, achieve far better performance by reducing, but not eliminating, side-channel leakage by leveraging non-deterministic behavior. Unfortunately, the complexity introduced by this non-determinism often makes it difficult to determine how much leakage is actually allowed by these schemes. We identify three key goals in studying the side-channel leakage of obfuscating defense schemes. First, we desire a unifying model that lets us represent wide classes of obfuscating schemes, which can significantly vary in practice. For instance, randomized caches aim to obscure spatial collisions between the attacker and victim, while DRAM traffic shapers attempt to obscure the timing of collisions. Second, we identify the need for strategies to model real victim and attacker programs. The amount of side-channel leakage can often be heavily dependent on the victim and attacker under study. For instance, a victim which has large variations in its cache footprint may leak more information than victims with less variations. Finally, we desire a way to quantify the leakage of different victims, attackers, and obfuscation scheme parameters, allowing mitigation designers to comprehensively evaluate their schemes. To this end, we present Metior, a comprehensive model to quantitatively evaluate the effectiveness of obfuscating side-channel mitigations. Metior describes a flow of side-channel information using a random variable model, converting the detailed study of the interactions between the attacker and victim's access patterns into a mathematical exercise. This model allows Metior to evaluate and compare the leakage of different state-of-the-art obfuscation schemes, such as skewed Caesar, real victim applications, such as RSA and AES, across wide classes of attacks. This leakage quantification can help mitigation designers better understand and compare the leakage of their defense schemes prior to deployment. Using Metior can reveal surprising insights into the underlying properties of these state-of-the-art schemes. Using Metior, we study the effectiveness of varying attack strategies on randomized caches, such as skewed Caesar. We demonstrate that under certain configurations, probabilistic prime and probe attacks may primarily exploit cache occupancy effects, rather than leaking information through targeted set collisions. We hope to see you at our presentation at the security session on Monday, June 19th at 9:15 a.m.